Last section, you guessed it, story problems, right? Story problems. We always apply things at the end, right? You might look at these formulas and say like, they look kind of familiar. They're the same formulas we did in the exponential chapter. One of them might look a little different, like this one I think uses different letters. PERT we used before, that one might be a little new, but they're really all the same formula. If you look at the explanations of the variables, final amount, final amount, final amount, initial amount, initial amount, initial amount, rate, rate, a constant that's actually a rate as well, and then of course time. So you don't have to memorize the formulas, right? Yay, you don't have to memorize them. You'll just need to know which one to use when. So this one is going to use for growth and decay, for continuously compounded interest, and then anything that's appreciating or depreciating. So we just have three little problems here, kind of one of each. So here it's got K. Well, the only one with a K in it is this one. How long will it take 2 bacteria to go to 1,000 bacteria? So here's the thing. Last time when we did this, we were always solving for the final amount. We would say, how long, not how long, like how many bacteria will there be after 5 years or something, where we would just type this part in your calculator. Now we're actually solving for the t, for the time, for the exponent. So we're going to need to first isolate, divide both sides by 2. 500 is equal to e to the 0.775t. And then how do we get that t out of the exponent? Right, we're going to take the natural log of both sides. So the natural log of 500 is equal to, it's going to come down here, 0.57775t, natural log of e. Why do you think I did natural log? Right, because the natural log of e is equal to 1 because e to the first is e. So this essentially like disappears, and we would just divide both sides by 0.775, and I would just type that into my calculator and get t is approximately 8.02 years. And I'll tell you on each story problem what we want you to round it to. So this is 100th, 8.02 years. Perfect. Next one, $100 deposited in a savings account. Interest compounded what? Continuously. Continuously tells us it's the PERT formula. In how many years will it be worth $200? So I'm just going to plug in what I know. Right? Solve it, dividing both sides by 100. 2 equals e to the 0.06t. Because it's an e problem, I'm going to take the natural log of both sides. The natural log of e is 1. Multiplying by 1 doesn't change anything. So I'm going to divide both sides by 0.06. Type it in my calculator, 11.55 years. Perfect. Last one has got to be that other formula, right? So a house is appreciating. So they want to know when it will be worth $300,000 if it's currently at $250,000 and it appreciates plus at a rate of 0.03 a year. By the way, the difference between the appreciation and the depreciation, that's this plus or minus. So appreciate is plus and depreciate is minus. And we had that before. So back down here, here we go. What do I have to do first? Divide both sides by 250,000. Divide both sides by 250,000. So I get 1.2 equals 1.03 to the n. Now this doesn't have an e in it, so I would just go back to log and bringing that n down in front, log 1.03. Divide both sides by log 1.03. And this is going to equal approximately, and again, round to the nearest hundredth, 6.17 years. So it's pretty straightforward. You don't have to memorize the formulas. There will be a story problem from each formula on the test. You guessed it, story problems.